Hello students, today we will learn about looping control structures. In the previous lessons we have learned how to write statements in a sequence. We have also learned to execute or skip the statements depending on some condition or to let the statements be executed in a sequence depending on the requirement of the logic in a program. In this lesson we will study about the looping control structures which have an iterative nature. Iteration means repeating a particular process or a set of statements according to the requirements of the program. Although performing a task in a repeated manner is a bad programming practice, yet sometimes in real-world scenarios, we may have to repeat a particular task many times. Similarly, there are situations where we have to repeat one or more statements a number of times. In Java, this is achieved by using loops. The loop constructs of Java repeat a set of statements till the time the specified condition remains true. This specific condition, which basically controls the loop, is referred to as loop control. This condition returns the Boolean true value or the false value. Control variable. It is a variable that controls the loop and also works as the loop counter. Before entering a loop, the control variable must be initialized. The initialization expression gives the loop variable its first value. A loop counter also determines the number of times the body of a program loop will execute. It is incremented or decremented when counting down each time the loop body is executed. Test condition. Every loop contains a test condition that checks whether the loop has to be repeated or terminated. Depending on the condition, control enters into the body of the loop and executes till the condition becomes false. Body of the loop. It is a set of statements that are repeatedly executed within the loop. In a loop, first, the test condition is evaluated, and if it is true, the body of the loop is executed. If the test condition evaluates to false, the loop is terminated. Step value. It determines the increment or decrement of the control variable till the test condition becomes false. Based on the nature of the iterations, Java provides three standard looping control structures: for loop, while loop, do-while loop. Before moving forward, let us first discuss about for loop. A for loop is used to repeat a block of statements enclosed in curly braces. It contains three optional expressions enclosed in parentheses and separated by semicolons, followed by statements executed in the loop. The general syntax of for loop is as follows. For initialization expression 1, semicolon, conditional expression 2, semicolon, increment or decrement expression 4, parentheses, curly braces in. Java statement 3, semicolon, curly braces close. Body of loop. For loop works in the following manner. Number 1. The initialization expression is executed only once at the beginning of the for loop. This step allows you to declare and initialize any loop control variable. Number 2. Thereafter the test expression is evaluated. If the condition is true, then the body of the loop will be executed. Otherwise, the loop is terminated, and the execution continues with the statements that immediately follow the loop. Number 3. The control is transferred back to the for statement after executing the last statement in the loop. Now the execution of update expression takes place. That is, the control variable is incremented by using an assignment statement, such as I equals to I plus 1, and the new value of the control variable is again tested to see whether it satisfies the loop condition. If the condition is satisfied, the body of the loop is again executed. This process continues till the test expression becomes false. For loop is also called an entry control loop because the body of the loop is executed only after the condition evaluates to true. The loop will never be executed if the condition is false in the beginning. Let us understand the concept of the for loop with the help of a program. Example. Let us create a program that will print your name 10 times using a for loop. Example. Create a program to print the numbers from 5 to 50 with a gap of 5 between each of them, such as 5, 10 till 50. Class numbers, braces in, public static void main bracket in string args bracket close, braces in, int I semicolon, variable I is declared. For bracket in I equals to 5 semicolon I is smaller than equal to 50 semicolon I plus equals to 5 bracket close. Braces in system.out.println bracket in I bracket close semicolon, printing the value of I every time. Braces close, braces close, braces close. Example. Create a program to print the first 10 numbers in reverse order. Class reverse, braces in, public static void main bracket in string args bracket close, braces in, int I semicolon. For I equals to 10 semicolon I is greater than equal to 1 semicolon I minus minus bracket close. Braces in system.out.println bracket in I bracket close semicolon, braces close, braces close, braces close. Example. Write a program to print cube of numbers 1 to 5. Class cube, braces in, public static void main bracket in string args bracket close, braces in, int I comma cu equals to 0 semicolon. For bracket in I equals to 1 semicolon I is smaller than equal to 5 semicolon I plus plus bracket close. Curly braces in, cu equals to I into I into I semicolon. System.out.println bracket in double quote in cube of double quote close plus I plus double quote colon double quote close plus cu bracket close semicolon. Braces close, braces close, braces close. Example. Write a program to create a table of a given number. Class table, braces in, public static void main bracket in int number bracket close, braces in, int I semicolon, system.out.println bracket in double quote in entered number is double quote close plus number bracket close semicolon. For bracket in I equals to 1 semicolon I is smaller than equal to 10 semicolon I plus plus bracket close. Braces in system.out.println bracket in number plus double quote in asterisk double quote close plus I plus double quote in equals to double quote close plus bracket in number asterisk I bracket close semicolon. Braces close, braces close, braces close. Example. Write a program to accept a number from the user and display its divisors. Class divisors, braces in, public static void main, bracket in int number, bracket close, braces in int I semicolon, system.out.println, bracket in double quote in divisors of double quote close plus number plus double quote close r colon double quote close bracket close semicolon. For bracket in I equals to 1 semicolon I is smaller than equal to number semicolon I plus plus bracket close. Braces in, if bracket in number percentage I equals to 0 bracket close, system.out.println bracket in I bracket close semicolon, braces close, braces close, braces close. Example. Create a program to tabulate the function f a equals to bracket in a plus 1.5 into a plus 5 bracket close divided by bracket in a minus 3 bracket close for a equals to minus 10 to 10. Note that a should have values minus 10, minus 8, minus 6 to 6, 8, 10. Public class function, braces in, public static void main, bracket in string args bracket close, braces in int a equals to 0 semicolon double fa semicolon. For bracket in a equals to minus 10 semicolon a is smaller than equal to 10 semicolon a equals to a plus 2 bracket close. Curly braces in, fa equals to bracket in a into a plus 1.5 asterisk a plus 5 bracket close divided by bracket in a minus 3 bracket close semicolon. Formula function fa. System.out.println bracket in double quote in for a equals to double quote close plus a plus double quote in f bracket in a bracket close is double quote close plus fa plus double quote in slash n double quote close bracket close semicolon. Braces close, braces close, braces close. Okay students, let us understand variations in for loop. A for loop can have multiple variations that make it more flexible and efficient. Let us discuss the variations of the for loop. Number 1. Multiple initialization and update expressions. A for loop may contain multiple initialization and update expressions. The multiple expression must be separated during commas. int I, j semicolon. For bracket in I equals to 1, j equals to 20 semicolon I is smaller than equal to 10 semicolon I plus plus j minus minus bracket close. Multiple initialization and multiple update expression. Braces in, system.out.println bracket in I plus double quote plus j bracket close semicolon braces close. In the above mentioned statements, we have initialized two variables in a single for loop. This loop will display numbers from 1 to 10 and 20 to 11. Let us understand this through some programs. Students, let us understand this through an example. Write a program to print the following output using multiple initializations. Class check 1, braces in, public static void main bracket in string args bracket close, braces in int I, k semicolon. For bracket in I equals to 1, k equals to 0 semicolon I is smaller than equal to 10 semicolon k plus equals to I, I equals to I plus 2 bracket close. Braces in, system.out.println bracket in I bracket close semicolon, braces close, braces close, braces close. Example: write a program to print the pattern of a star as shown in the output box using string concatenation. Class pattern. Braces in public static void main bracket in string args bracket close. Braces in string star equals to double quote in asterisk double quote close semicolon. INTI semicolon for bracket in I equals to 1 semicolon I is smaller than 10 semicolon I plus plus bracket close. Braces in system.out.println bracket in I plus double quote plus str bracket close semicolon. str equals to str plus double quote in asterisk double quote close semicolon. Braces close, braces close, braces close. Example: write a program to print first 10 powers of 2. Class power. Braces in public static void main bracket in string args bracket close. Braces in INTI, comma n equals to 2, comma power equals to 2, semicolon. For bracket in I equals to 1, semicolon I is smaller than equals to 10, semicolon I plus plus, bracket close. Braces in system.out.println bracket in n plus double quote caret double quote close plus I plus double quote equals to double quote plus power bracket close semicolon. Power asterisk equals to 2 semicolon. Braces close, braces close, braces close. Number 2. Optical expressions. By now you are familiar that a for loop contains 3 types of expressions: initialization expression, test expression, condition, and an update expression. But all these expressions are optional. That is, we can skip any or all these expressions depending upon the requirement of a program. Case 1. INTI equals to 2 semicolon. For bracket in semicolon I is smaller than equal to 20 semicolon I equals to I plus 2 bracket close. Braces in system.out.println bracket in I bracket close semicolon. Braces close. In the above mentioned loop we have not included the initialization expression because I has already been initialized. Case 2. INTI is equal to 2 semicolon. For bracket in semicolon I is smaller than equal to 20 semicolon bracket close. Braces in system.out.println bracket in I bracket close semicolon. I equals to I plus 2 semicolon. Braces close. The above mentioned loop not include the initialization and update statements because the initialization process has already been done and the statement I is equal to I plus 2 is performing the increment process in the block. Number 3. Infinite loop. A for loop will execute its statement block infinite number of times if we skip the condition. If the test expression condition is not present in the loop, it will never return false. Hence, it will execute endlessly and become an infinite loop. Case 1. INTI semicolon. For bracket in I equals to 1 semicolon. Semicolon I equals to I plus 1 bracket close. Braces in system.out.println bracket in I bracket close semicolon. Braces close. Case 2. INTI semicolon. For bracket in semicolon semicolon bracket close. Braces in system.out.println bracket in I bracket close semicolon. I equals to I plus 1 semicolon. Braces close. Both the above mentioned loops are finite loops as they do not have a testing condition. Also, if the test condition always evaluates to true, then the for loop becomes an infinite loop. Case 3. I semicolon. For bracket in I equals to 1 semicolon I is smaller than equal to I semicolon I plus plus bracket close. Counter variable. Braces in system.out.println bracket in I bracket close semicolon. Braces close. Here I is smaller than equal to I will always be true. Number 4. Empty loop. A loop without any statement in its body is called any empty loop. INTI semicolon. For bracket in I equals to 2 semicolon I is smaller than 500 semicolon I plus plus bracket close. Curly braces in, curly braces closed. The above mentioned loop is an empty loop that has no statement in its body. These loops do not perform any action and are used for the purpose of time delay. The time delay property is used to pause the program for a small interval. Let us understand this through an example. When you withdraw a certain amount from the ATM machine, it shows the account balance for a few seconds on the screen so that the user can get enough time to read the message. This is how the time delay feature helps by pausing the program. Number 5. Declaration of variables in a loop. We can declare and initialize a variable at the same time in a for loop. For bracket in INT I is equal to 1 semicolon I is smaller than equal to 10 semicolon I equals to I plus 1 bracket close. Braces in system.out.println bracket in I bracket close semicolon. Braces close. In the above mentioned loop, the variable I has been declared and initialized. This variable has a limited scope and can be available only within the loop. Okay, students, let us know more. A counter is the variable that controls and counts the iteration of a loop in a program. It increases with each iteration of a loop. Counters need two things in order to function. Number 1, an initial value. Number 2, an incremental value. The initial value is usually 0 and must be located outside the loop. This incremental value tells the program what to count by and must be located inside the loop. Let us discuss about while loop. The while loop is the simplest of all looping structures in Java. In general, this loop can be applied to a program where the number of iterations are not known beforehand. The syntax of while loop is initialization expression semicolon while bracket in test condition bracket close. Braces in Java statement semicolon braces close body of loop. Start test condition body of loop true. Stop false. The while loop is an entry control loop. The while loop keeps on executing the block of statements till the specified test condition evaluates to true. When the test condition becomes false, the program control is transferred out of the loop and passes to the statement after the body of the loop. In a while loop, a loop control variable should be initialized before the loop begins, as a variable cannot be used in an expression before initialization. The loop variable should be updated inside the body of the while loop. Students, note the fact: do not use control variables with float values. It will produce inaccurate tests as float values are approximate. Example: create a program to calculate the sum of first 10 even and odd integers. Example: write a program to enter a 3-digit number and check whether the number is an Armstrong number or not. A number is an Armstrong when the sum of all digits is raised to the power of n, where n is the number of digits. Sample input: 153 bracket in 1 plus 5 plus 3 bracket close is equal to 153. Public class Armstrong, braces in, public static void main bracket in int n bracket close, braces in, int a comma number comma s equals to 0 semicolon, number equals to n semicolon, while bracket in n is greater than 0 bracket close, curly braces in, a equals to n percentage 10 semicolon, s is equal to s plus a into a semicolon, n equals to n by 10 semicolon, braces close. If bracket in number equal to s bracket close, system.out.println bracket in double quote in the number double quote close plus number plus double quote in is an Armstrong number double quote close bracket close semicolon. Else system.out.println bracket in double quote in the number double quote close plus number plus double quote in is not an Armstrong number double quote close bracket close semicolon, braces close, braces close. Output: the number 153 is an Armstrong number. Example: write a program to calculate the sum of first 100 natural numbers and print their sum. Class sum, braces in, public static void main bracket in string args bracket close, braces in, int sum equals to 0 semicolon, int I equals to 1 semicolon, while bracket in I is smaller than equal to 100 bracket close, braces in, sum is equal to sum plus I semicolon, accumulator, I equals to I plus 1 semicolon, braces close. System.out.println bracket in double quote in the sum of numbers from 1 to 100 is double quote close plus sum bracket close semicolon, braces close, braces close. Output: the sum of numbers from 1 to 100 is 5050. For example, write a program that will find the reverse of a given number. Public class reverse, braces in, public static void main bracket in int number bracket close, braces in, int reverse equals to 0 semicolon, int digit semicolon. System.out.println bracket in double quote entered number is colon double quote close plus number bracket close semicolon, while bracket number is greater than 0 bracket close, braces in, digit is equal to number percentage 10 semicolon, extract the last digit, reverse equals to bracket reverse into 10 bracket close plus digit semicolon, number equals to number divided by 10 semicolon, drop last digit and repeat the loop, braces close. System.out.println bracket double quote in reverse of given number is colon double quote close plus reverse bracket close semicolon, curly braces close, curly braces close. Example: write a program that prints the series showing multiplication of two consecutive numbers up to 10. Public class consecutive, braces in, public static void main bracket in string args square brackets bracket close, braces in, int n1 equals to 1 semicolon, int result is equal to 0 semicolon. While bracket in n1 is smaller than equal to 10 bracket close. Braces in result equals to n1 into bracket in n1 plus 1 bracket close semicolon. System.out.println bracket in n1 plus double quote in asterisk double quote close plus bracket in n1 plus 1 bracket close plus double quote in equal to sign double quote close plus result bracket close semicolon. n1 is equal to n1 plus 1 semicolon. Braces close, braces close, braces close. Example, write a program to print the pattern up to 7 terms as given in the output box. Public class pattern. Braces in public static void main bracket in string arg square brackets bracket close. Braces in int a equals to 0, comma p equals to 1 semicolon. Double s equals to 0 semicolon. While bracket in a is smaller than equal to 6 bracket close. Braces in s equals to s plus mat dot paw bracket in 10 comma a bracket close semicolon. P equals to bracket in int bracket close s semicolon. Bracket in int bracket close converts a double to an int. A equals to a plus 1 semicolon. System.out.println bracket in p bracket close semicolon. Braces close, braces close, braces close. Example, create a program that will display the elements of Fibonacci series between 1 and 100 using a while loop. In Fibonacci series, each number is the sum of its previous two numbers. It starts with 0, 1. Public class FibDemo. Braces in public static void main bracket in string arg square brackets bracket close. Braces in int n1 equals to 0, comma n2 is equal to 1 semicolon. Int sum is equal to 0 semicolon. System.out.println bracket in double quote in Fibonacci series is as follows: colon double quote close bracket close semicolon. System.out.println bracket in n1 plus double quote in comma double quote close plus n2 bracket close semicolon. While bracket in sum is smaller than equal to 100 bracket close. Curly braces in sum equals to n1 plus n2 semicolon. System.out.println bracket in sum bracket close semicolon. n1 is equal to n2 semicolon. n2 is equal to sum semicolon. Braces close, braces close, braces close. Fibonacci series is as follows. Example, create a program to print the factorial of a number. Factorial number is 1 into 2 into 3 into 4 into 5 till n. Public class factorial. Braces in public static void main bracket in int number bracket close. Braces in system.out.println bracket and double quote in entered number is colon double quote close plus number bracket close semicolon. int fact equals to 1 comma x equals to 1 semicolon. While bracket in x is smaller than equal to number bracket close. Braces in fact equals to fact into number semicolon. X plus plus semicolon braces close. System.out.println bracket in double quote in factorial of a given number is colon double quote close plus fact bracket close semicolon. Braces close, braces close. Okay, students, let me tell you about variations in while loop. Similar to for loop, the while loop can also have several variations. A while loop can either be converted into an empty loop or an infinite loop. Number 1. While loop as an empty loop. If we do not write any statement in the body of a while loop, it becomes an empty loop. Such a loop can also be used for time delay. int I equals to 0 semicolon. While bracket in plus plus I is smaller than equal to 50 bracket close. Curly braces in, curly braces close. The above mentioned loop is an empty loop which will pause the program for 50 iterations of the while loop. Number 2. While loop as an infinite loop. If we do not write the increment or decrement statements in a while loop, it becomes an infinite loop. int I is equal to 0 semicolon. While bracket in I is smaller than equal to 50 bracket close. Curly braces in. System.out.println bracket in I bracket close semicolon. Braces close. In the given program segment, the value of I will never be greater than 50 because we are not updating it. Hence, I will always be less than 50 and the loop will execute endlessly. The above loop can be converted into a finite loop if we write an update statement in the body of the loop. int I is equal to 0 semicolon. While bracket in I is smaller than equal to 50 bracket close. Curly braces in. System.out.println bracket in I bracket close semicolon. I plus plus semicolon. Braces close. We can also create an infinite while loop without any loop variable. While bracket in true bracket close. Curly braces in. System.out.println bracket in double quote in infinite while loop double quote close bracket close semicolon. Curly braces close. In the above example, we have used a Boolean literal true as a condition that will remain true. Hence, the loop will never terminate. Alright, let us discuss about do-while loop. Just like the while loop, the do-while loop also consists of a block of code and a condition. It is generally preferred when the number of iterations are not known beforehand. The while loop first checks the condition and then executes the statement. On the other hand, do-while loop first executes the block of statements and then checks the condition. If the condition is true, the program continues to evaluate the code within the block once again. This iteration continues as long as the condition is true. When the condition becomes false, the loop will be terminated and the control moves to the statement that appears immediately after the while loop. The do-while is an exit control loop since the body of the loop is executed first and then the test condition is evaluated. If it evaluates to false, then the loop is terminated. Otherwise, it is repeated. This means do-while loop always execute at least once, even if the condition is evaluated to false. Students, let us know more. Exit control loop, post-test loop. In this loop, the test condition is evaluated at the end of the body of the loop and therefore the body is executed unconditionally for the first time. Example, do-while. If it evaluates to false, then the loop is terminated, otherwise it is repeated. Some important points about the do-while loop are as follows. Number 1. The while statement of do-while must be terminated by a semicolon. Number 2. The condition to be evaluated should be given within parentheses. Students, let us understand this through an example. Write a program that accepts the number and prints n numbers. Example: write a program that reads marks in 5 subjects and calculates the total marks. Import java.util.scanner semicolon. Class subjects. Curly braces in. Public static void main bracket in string arg square brackets bracket close. Curly braces in. Scanner sc equals to new scanner bracket in system.in bracket close semicolon. intn semicolon. int count is equal to 1 semicolon. int total is equal to 0 semicolon. Do. Braces in. System.out.println bracket in double quote and enter marks in subject double quote close plus bracket in count bracket close plus double quote and colon double quote close bracket close semicolon. N equals to sc dot next int brackets semicolon. Total is equal to total plus n semicolon. Count is equal to count plus 1 semicolon. Curly braces close. While bracket in count is smaller than equal to 5 bracket close semicolon. System.out.println bracket in double quote in total marks in double quote close plus count plus double quote in subjects are colon double quote close plus total bracket close semicolon. Curly braces close. Curly braces close. Students, if you want to know more about looping control structures, visit this site http://in.wiki-versity.org/wiki/java_second_minus_looping. Example: write a program to accept a number and check whether the number is a palindrome or not. A number is said to be palindrome if the new number obtained after reversing the digits is the same as the original number. For example, 121 is a palindrome number. Public class palindrome. Braces in. Public static void main bracket in int number bracket close. Braces in. System.out.println bracket in double quote in entered number is colon double quote close plus number bracket close semicolon. intn comma d semicolon. int rem equals to 0 semicolon. n equals to number semicolon. Do. Braces in. d equals to n percentage 10 semicolon. Rem equals to rem into 10 plus d semicolon. N equals to n by 10 semicolon. Curly braces close. While bracket in n exclamatory mark equal to 0 bracket close semicolon. If bracket in rem equals to number bracket close. Curly braces in. System.out.println bracket in double quote in entered number is palindrome full stop double quote close bracket close semicolon. Curly braces close. Else. Curly braces in. System.out.println bracket in double quote in entered number is not a palindrome full stop double quote close bracket close semicolon. Curly braces close. Curly braces close. Curly braces close. Example: create a program to find the sum and average of first n positive integers. Class group. Curly braces in. Public static void main bracket in int n bracket close. Curly braces in. Float average semicolon. int I equals to 1 comma sum is equal to 0 semicolon. System.out.println bracket in double quote in entered value is double quote close plus n bracket close semicolon. Do. Braces in. Sum equals to sum plus I semicolon. I equals to I plus 1, semicolon. Braces close. While bracket in I is smaller than equal to n, bracket close, semicolon. System.out.println, bracket in double quote in sum of first n positive integers is double quote close plus sum, bracket close, semicolon. Average equals to bracket in float, bracket close, sum slash n, semicolon. System.out.println, bracket in double quote in average of integers is double quote close plus average, bracket close, semicolon. Curly braces close, curly braces close. Students, let me tell you about nested loops. A loop may contain another loop in its body, thus creating a loop within a loop. This process of loop is called nested loop. In such situations, the inner or outer loops can be of any type: for loop, while loop, or do while loop. However, the inner loop must execute before the outer loop and should have a different control variable from the outer loop. The outer loop executes once the inner loop is completely finished. Syntax: for bracket in expression 1, bracket close, curly braces in, for bracket in expression 2, bracket close, curly braces in, system.out.println, bracket in statement, bracket close, semicolon, curly braces close, curly braces close. Students, let us understand this through an example. Write a Java program that prints the following pattern. Class pyramid. Braces in, public static void main, bracket in string, square brackets, arcs, bracket close. Curly braces in, for bracket in int I equals to 5, semicolon, I is greater than equal to 1, semicolon, I minus minus, bracket close. Curly braces in, for bracket in int j equals to 1, semicolon, j is smaller than equal to I, semicolon, j plus plus, bracket close. Nested for loop. Curly braces in, system.out.print, bracket in j, bracket close, semicolon, braces close, system.out.println, brackets, semicolon, braces close, braces close, braces close. Practice questions. Write programs to display the following patterns. Example: write a Java program to accept a number from the user and print a dual pyramid using asterisk depending on the number entered by the user. Import java.util. semicolon. Class pattern dual. Curly braces in, public static void main, bracket in string, arc, square brackets, bracket close, curly braces in, scanner sc equals to new scanner, bracket in system.in, bracket close, semicolon, system.out.print, bracket in double quote in, enter the size of pattern you want, double quote close, bracket close, semicolon, int n equals to sc.next int, bracket, semicolon, int I comma j, semicolon, for bracket in I equals to 1, semicolon, I is smaller than equal to n, semicolon, I plus plus, bracket close, curly braces in, for bracket in j equals to 1, semicolon, j is smaller than equal to n, semicolon, j plus plus, bracket close. Nested loop. Curly braces in, if bracket in I equals to j, bracket close, curly braces in, system.out.print, bracket in double quote close, bracket close, semicolon, curly braces close, else curly braces in, system.out.print, bracket in double quote in asterisk double quote close, bracket close, semicolon, curly braces close, curly braces close, system.out.println brackets semicolon, curly braces close, curly braces close, curly braces close. Alright, let us understand comparison of loops. Though loops can be used in almost all situations, yet there are certain situations where one loop fits better than the other. Let us have a glimpse of the comparison of loops in the following table. For, while, do while. The for loop contains all the three statements together: initialization, condition, updation. For loop starts the initialization process and repeats a particular task for finite number of times. While. We cannot initialize and increment the values in the condition section of the while loop. Do while. We cannot initialize and increment the values in the condition section of a do while loop. For. The for loop is generally used when the number of iterations are known beforehand. While. The while loop should be preferred if the number of iterations is dependent upon some control variable. Do while. The do while loop should be preferred when the number of iterations is dependent upon the user's response. For. It is an entry control loop. In for loop, a statement will be executed after each and every iteration in the loop and usually increments or decrements the loop counter. While. The while loop is an entry control loop. In while loop, the test expression is evaluated at the beginning, so it may not even enter into the loop if the condition is false. If the test expression evaluates to true, the while statement executes the statements in the while block. The loop continues till the condition is true. Do while. The do while is an exit control loop. In do while, the test expression is evaluated at the bottom after executing the body of loop. If the condition is true, then again the loop body is executed and this process continues until the condition becomes false. Thus, do while always run at least once. For. In for loop, all the three statements are separated from each other by using semicolon in a single line. While. In while loop, no semicolon is required after the control statement. Do while. In do while loop, the while statement of do must be terminated by a semicolon. Let us talk about jump statements. The jump statements are used to transfer the program control unconditionally to some other location. Java provides three types of jump statements: break statement, continue statement, and return statement. Break statement. Break statement in Java programming is used to take the control out of the loop control structure. The break statement enables a program to skip over a section of code in a loop and executes immediate statements following the body of the terminated statement. We have already seen the significance of the break statement while using switch statement. Now let us see the working of break statement with various loops. Let us understand this through some example. Create a program to demonstrate the use of break statement. The program will terminate the while loop as soon as it encounters the break statement. Example: write a program to print square of first 20 natural numbers. However, if a square is encountered that is divisible by 2 and 5, the program should stop. Public class square, braces in, public static void main, bracket in, string arg, square bracket close, braces in, int n, comma, square equals to 0, semicolon. For bracket in n equals to 1, semicolon, n is smaller than equal to 20, semicolon, n plus plus, bracket close. Braces in, square equals to n into n, semicolon. System.out.println, bracket in square, bracket close, semicolon. If bracket in square %2 equal to 0 and square %5 equal to 0, bracket close. Break semicolon, braces close, braces close, braces close. Break statement executed as 100 is divisible by 2 and 5. Example: write a program that prints the power series 2 up to 10 terms but stops as soon as the number exceeds 100. Public class power series, braces in, public static void main, bracket in, string arg, square bracket close, braces in, double term equals to 0, semicolon, int n equals to 1, semicolon, do, braces in, term equals to math.pow, bracket in 2, comma, n, bracket close, semicolon. If bracket in term is greater than 100, bracket close. Break semicolon. System.out.println, bracket in term, bracket close, semicolon. n plus plus, semicolon, braces close. While bracket in n is smaller than equal to 10, bracket close, semicolon. Braces close, braces close. Continue statement. Just like the break statement, the continue statement is also used to skip a section of code. While the break statement terminates the execution of the current block, the continue statement skips the rest of the statements written in that block and transfers the control to the next iteration of the loop. In a for loop, the continue statement skips the rest of the statements for the particular value and shifts the control to the condition statement of the for loop for the next iteration. Similarly, if a while loop finds a continue statement, the compiler would ignore the rest of the statements written in the loop block and shift the program control to the condition statement of the while loop for the next iteration. Also in do-while loop, when the loop finds a continue statement, the program control passes to the conditional test. Students, let us know more. Continue statement skips the loop and re-executes loop with new condition. This statement can be used only in loop control statements. Example: let us create a program to demonstrate the functionality of continue statement. In the program output, we can see that if the number is an even number, the program executes the continue statement. Hence, it skips the next statements and moves back to the conditional statement. Example: write a program to print numbers up to 20 and skip the program if the number is 17. Public class numbers, braces in, public static void main bracket in int a bracket close, curly braces in do, curly braces in, if bracket in a is equal to 17 bracket close, curly braces in a plus plus semicolon, continue semicolon, curly braces close, system.out.println bracket in double quote in value of a colon double quote close plus a bracket close semicolon, a plus plus semicolon, braces close, while bracket in a is smaller than equal to 20 bracket close semicolon, braces close, braces close. Alright, let us discuss about some practice questions. What will happen if the first a plus plus semicolon is not written in the program? Example, write a program to print series of 5n plus 2, but skip the multiples of 3. Print up to first 10 terms of the series. Public class multiples, braces in, public static void main bracket in, string args square brackets bracket close, braces in, double term equals to 0, comma, I semicolon. For bracket in I equals to 1 semicolon, I is smaller than equal to 10 semicolon, I plus plus bracket close, braces in, term equals to 5 into I plus 2 semicolon. If bracket in term percentage 3 equals to 0 bracket close, braces in, continue semicolon, braces close, system.out.println bracket in term bracket close semicolon, braces close, braces close, braces close. Return statement. The return statement returns the control to the code that invoked it. This statement will be done in detail in the lesson Functions or Methods. Students, let us learn about labels and branching statements. Labels are used in programming to transfer the control of the program to any specific location. Since in Java we often use nested loop, therefore labels can be used before any loop in the program. The label is an identifier followed by a colon placed before the looping structure. You can label any of the loop or switches by using label statement and the break label to come out of the statement. Consider the following nested loop example where labeled loops are used and are terminated using a break statement. Example, write a program to display the number triangle as shown below. Public class number triangle, braces in, public static void main bracket in string arg square brackets bracket close, braces in, router colon, for bracket in int I equals to 0 semicolon, I is smaller than 10 semicolon, plus plus I bracket close, curly braces in, for bracket in int j equals to 0 semicolon, j is smaller than 10 semicolon, plus plus j bracket close, curly braces in, if bracket in j is greater than I bracket close, curly braces in, system.out.println bracket semicolon, continue router semicolon, curly braces close, system.out.print bracket in double quote close plus bracket in I into j bracket close semicolon, curly braces close, curly braces close, curly braces close, curly braces close. Let us understand programming practice. Example, create a program that will display numbers from 1 to 10 in both ascending and descending order. Public class for loop 1, braces in, public static void main bracket in string arg square brackets bracket close, braces in, for bracket in int I equals to 1 semicolon, I is smaller than equal to 10 semicolon, I plus plus bracket close, braces in, system.out.print bracket in I plus double quote, bracket close, semicolon, braces close, system.out.print ln, brackets, semicolon. For bracket in int I equals to 10, semicolon I is smaller than equal to 1, semicolon I minus minus, bracket close, braces in, system.out.print bracket in I plus double quote, bracket close, semicolon, braces close, braces close, braces close. Example, create a program that will accept a number from the user and display whether the number is a prime number or a composite number. Public class prime or composite. Braces in public static void main bracket in int number bracket close. Braces in if bracket in number is smaller than 2 bracket close. Braces in system.out.println bracket in plus number plus double quote in is neither prime nor composite number, full stop, double quote close, bracket close, semicolon, braces close, else braces in int I semicolon, int division is equal to 0 semicolon. For bracket in I is equal to 2 semicolon, I is smaller than number semicolon, I plus plus, bracket close. Braces in if bracket in number percentage I equals to 0 bracket close. Braces in div equals to 1 semicolon, break semicolon, braces close, braces close. If bracket in division is equal to 0 bracket close. If any division was successful, division will have a value of 1. Braces in system.out.println bracket in number plus double quote in is a prime number, full stop, double quote close, bracket close, semicolon, braces close, else braces in system.out.println bracket in number plus double quote in is a composite number, full stop, double quote close, bracket close, semicolon, braces close, braces close, braces close, braces close. Example, create a program that will accept two numbers and store them in variables start, underscore number and increase. It will then print the first 15 elements of a series starting from start underscore number. The next element of the series will be start number plus increase. Public class leap underscore list. Braces in public static void main bracket in int start underscore number comma int increase bracket close. Braces in system.out.println bracket in double quote in following series is starting from double quote close plus start underscore number plus double quote close and increasing its value by double quote close plus increase plus double quote in every time, full stop, double quote close, bracket close, semicolon. int number equals to start underscore number semicolon, int I semicolon. For bracket in I equals to 1 semicolon, I is smaller than equal to 15 semicolon, I plus plus, bracket close. Braces in system.out.println bracket in number bracket close semicolon. Number equals to number plus increase semicolon. Braces close, braces close, braces close. Students, let us know more. Accumulators. Accumulators are the variables which add some values in the program. They must have both the initial value and an incremental value. The incremental value is determined by a variable. Accumulators are used to keep a running total of numbers during successive passes through a loop. Example, Write a program to find the sum of the following series. Sum equals to 1 plus x plus x plus x plus x plus till plus x, where the values of x and n will be accepted from the user. Import java.util.scanner, semicolon. Public class sum of series, braces in public static void main, bracket in string arg, square brackets, bracket close, braces in int x semicolon, int n semicolon, double sum equals to 0 semicolon, scanner sc equals to new scanner, bracket in system.in, bracket close, semicolon, system.out.println, bracket in double quote, please enter the value of x, double quote, close bracket close, semicolon, x equals to sc.next int, bracket, semicolon, system.out.println, bracket in double quote, and please enter the value of n, double quote, close bracket close, semicolon, n equals to sc.next int, brackets, semicolon, system.out.println, bracket in double quote, and n equals to double quote close plus n, bracket close, semicolon, system.out.print, bracket in double quote, and elements of series are colon double quote close bracket close, semicolon, int I semicolon, for bracket in I equals to 0 semicolon, I is smaller than equal to n semicolon, I plus plus bracket close, braces in sum equals to sum plus math dot pop, bracket in x comma I, bracket close, semicolon, system.out.print, bracket in math.pop, bracket in x comma I, bracket close, plus double quote in comma double quote close bracket close, semicolon, braces close, system.out.println, bracket in double quote close bracket close, semicolon, system.out.println, bracket in double quote, and sum of series equal to double quote close plus sum, bracket close, semicolon, braces close, braces close. Example, write a program to find the sum of the following series. Sum equal to 1 exclamatory mark plus 2 exclamatory mark plus 3 exclamatory mark plus till n exclamatory mark. In the program, the value n will be accepted from user. Import java.util.scanner, semicolon. Public class sum of series, braces in public static void main, bracket in string arg, square brackets, bracket close, braces in int sum equals to 0 semicolon, int n semicolon, scanner sc equals to new scanner, bracket in system.in, bracket close, semicolon, system.out.println, bracket in double quote, and please enter the value of n, double quote close bracket close, semicolon, n equals to sc.next int, bracket, semicolon, system.out.println, bracket in double quote, and n equals to double quote close plus n, bracket close, semicolon, system.out.print, bracket in double quote, and elements of series are colon double quote close bracket close, semicolon, int I semicolon, for bracket in I equals to 1 semicolon, I is smaller than equal to n semicolon, I plus plus bracket close, braces in int fact equal to 1 semicolon, int j semicolon, for bracket in j equals to 1 semicolon, j is smaller than equal to I semicolon, j plus plus bracket close, braces in fact equals to fact into j semicolon, braces close, system.out.print, bracket in fact plus double quote in comma double quote close bracket close, semicolon, sum equals to sum plus fact semicolon, braces close, system.out.print, bracket in double quote bracket close, semicolon, system.out.println, bracket in double quote, and sum of series is equal to double quote close plus sum bracket close, semicolon, braces close, braces close. Example, write a program to accept a two-digit number. Add the sum of its digits to the product of its digits. If the value is equal to the number input, output the message special two-digit number, otherwise output the message not a special two-digit number. A special two-digit number is such that when the sum of the digits is added to the product of its digits, the result is equal to the original two-digit number. Example, consider the number 59. Sum of digits is equal to 5 plus 9 equals to 14. Product of its digits is 5 into 9, that is 45. Sum of the digits and product of the digits is 14 plus 45, that is 59. Import java.util. Class special underscore number. Braces in public static void main bracket in string arg square brackets bracket close. Braces in system.out.print bracket in double quote and enter a two-digit number, colon double quote close, bracket close semicolon. Scanner SC equals to new scanner, bracket in system.in bracket close semicolon. INT n equals to sc.next int bracket semicolon. INT first comma last comma sum comma pro semicolon. If bracket in n is smaller than 10, n is greater than 99 bracket close, checking whether entered number is two-digit or not. System.out.print ln bracket in double quote in invalid input exclamatory mark. Number should have two digits only, full stop, double quote close bracket close semicolon. Else, braces in first equals to n by 10 semicolon, finding the first digit. Last equals to n percentage 10 semicolon, finding the last digit. Sum equals to first plus last semicolon, finding the sum of the digits. Pro equals to first asterisk last semicolon, finding the product of the digits. If bracket in sum plus pro bracket close is equal to n bracket close, braces in system.out.print ln bracket in double quote in output colon the number double quote in plus n plus double quote close is a special two-digit number, full stop, double quote close bracket close semicolon. Braces close. Else, braces in system.out.print ln bracket in double quote in output the number is not a special two-digit number, full stop, double quote close bracket close semicolon. Braces close, braces close, braces close, braces close. Okay students, let us go through the points at glance of this chapter. Looping control structures have an iterative nature. Iteration means repeating a particular process or a set of statements according to the requirements of the program. A for loop is used to repeat a block of statements enclosed in curly braces. A for loop may contain multiple initialization and update expressions. The while loop keeps on executing the block of statements till the specified test condition evaluates to true. The do-while loop first executes the block of statements and then checks the condition. A loop may contain another loop in its body, thus creating a loop within a loop. This process of loop is called nested loop. Break statement in Java programming is used to come out of the loop control structure. The continue statement is also used to skip a section of code. Labels are used in programming to transfer the control of the program to any specific location.